So, I'm gonna start off with the reason as to why I really built these devices. So, I would see myself a lot in a situation where I've built something, or I have something, or if something breaks and I need to test it, and I don't really have access to power supplies or function generators. At least that makes sense. I didn't like using batteries in series or whatever just to get a certain voltage, or let's say I needed a more specific voltage to get something. So what I did was I just built this. This is a dual channel variable power supply powered off 18650s, so it is rechargeable. And right now I have it set to 5 volts, so I could just test this without the need of any other instruments. Now, there's a lot of instruments here, but this is not my workbench. So just imagine those aren't there, and this is all I have, like, at home. And I'd have another one. I made an ATX one. I'll show that one later. So I have it set to 5 volts, and now it's powering this circuit. So now nothing is even connected to the wall. I can carry this whole thing somewhere else if I really needed to. And I'm at a certain point where there's a flip-flop right here, and I don't know, like, I need to put inputs without just switching the wires by hand, because it's going to give you high impedance parts. It's going to be cases where there's going to be high impedance and it's floating and it's just not going to work out well. So I need something that goes from a high to low logic level on its own and efficiently, pretty much like a function generator. Again, those are pretty expensive, and well, that's where this thing comes in. Now, that's not the primary role of this, but it's just one feature. This just happened. I didn't even plan for this to happen, but I ended up needing this right now while I was working on this. So this mode right here is port manipulation, where you can control whatever you want on this port. It's not complete yet. This is just, right now all it does is turn on and off these pins. I'm planning to make it so that it generates waveforms on the pins and automates some tasks on them, but for now this is what it does. So right now, as I press this button, it's turning on and off the pin that's hooked up right here. From here, it's pin 22. Or pin 13, I'm sorry. So, right now, it was turning on and off the flip-flop. And if I wanted to test it, I could use my multimeter right here to test and make sure it's working. That's one case scenario. Another example would be, let's say I need my power supply, right? And this board comes in, and I need to test it really quickly, make sure everything works, or at least if there's two boards, I need to make sure there's no discrepancies. So right now 5 volts is just way too little, so I'm gonna crank it up to 11 is good enough, I guess. I gotta get that repaired. I gotta repair it. It'll get repaired within, like, today. So it should go up to 26 in the next video. So just like that, just from here, I'm not even connected to anything. I could go pick this up, go into the back and test another board, grab another board, put it on a bench and test it. Just like that. I don't even have to come back here and plug it in again or anything. So it's simple. Test it, just like that. And if I needed more than one power supply, there's two in here. And so yeah. It has voltage, current, power, energy, temperature, time, and everything, but I'll go into that further into the next video. I'm planning to make more devices like this, definitely. And this isn't necessarily that you're going to carry them around everywhere with you. Well, you could in the case of that one, but this is more of, you grab what you need quickly, and it's very versatile. So this one, batteries 18650, so they're rechargeable, high capacity, high power output. So it has everything I guess I would need in a power supply. Even if it wasn't portable, it's good enough to be a bench power supply on its own.